And I guess to clarify, to build on what Nick was saying, again, Colorado, US 34, flooding in 2013. You had the ER, the emergency action, and then came back later and did the PR, the permanent repairs. And that's exactly what's going on here is, we have been supporting this corridor since 2019, obviously progressing work. Then you had your flood event in 2022. And so I think that gave both WFL and Park knowledge and comfort that, hey, we need an ER action, get the Lifeline Road open. Again, only winter access to Cook City. So that had to be open by October 30th. And then, hey, looking ahead, we know we're going to be doing construction projects on this corridor to build the park preferred width, improve visitor use features. And at that time, hopefully rectify anything that was maybe done, in the hasty ER fashion. Okay, so this last part, we're going to talk about incorporating resilient design into the highway systems. Obviously, we've talked about some threats. So what are solutions and ways that we can build the highway system so it's not compromised in those future events? Everything we talked about so far has been fluvial hazard. So I'm going to first remind you that there's some geohazards out there, give a quick glimpse at some of the geohazards that we are considering. Next, move to what we're just really called solution categories. What are the types of solutions that we're seeing we could implement on this corridor to make a more resilient highway? And then 3 and 4 kind of go hand in hand. What are the frameworks we're using to evaluate and compare options? And then notably, what's a benefit cost assessment and how is that being used? And then finally wrap it up with some takeaways. I'll figure this out by the end. Okay, so what you're seeing on the screen here is a plot of landslides, one of the key geohazards in this corridor. It's from our geotechnical subconsultant, BGC, and they start with a desktop exercise that you can do at scale. So satellite data, publicly available, LiDAR, terrain, whatnot. So you can do a lot from your desk to get started. And really what they want to do is identify, hey, where are some landslide areas? And then, okay, well, are they active? Are they inactive? And do they even reach the road? And so based on all that information, you can then say, all right, where do I want to focus my efforts, looking in more detail and analyzing things. But this is a snapshot, at least, of where you kind of start. And you can see we've got some active landslides that, are close to the road. So something that we definitely want to consider as we move to, design this roadway. Other big geohazard are debris flows. And these are events where you mobilize large amounts of soil, rock, mass, I guess historically generally triggered by some rain events, bringing all that down the hillside. The dry creek areas that I mentioned earlier at the start of the project are where these are very prone to happen. So we got these dry creek beds higher up the mountain. You've got sediment and debris that's just hanging out up there waiting for something to trigger it. You can see, looking at this is a pre-flood photo of the TLF Creek crossing, pretty benign. I mean, you got vegetation in the channel upstream, downstream, small cobbles, nothing too eye-catching. But then you move forward to a photo taken probably the month or even week after the flood event. And again, you have mobilized tremendous amounts of material from high up in the mountains, brought those down through that canyon. These move slower than flash floods, more just think of big momentum. There's a lot of energy and just material coming down. And notice the trees there. It's not just the rocks and the soil. You are entraining other hazards and debris that are a threat to the system. All right, I'm going to pivot back to fluvial hazards. And one of the first things we're doing on this corridor, even pre-flood event, is channel migration zone mapping. And you're seeing one such map here on the screen from our hydraulic subconsultant Respect that Karen mentioned earlier. This also starts desktop exercise. You're concerned about relative water surface elevations. What's the water surface elevation relative to terrain? Supplement that with some ground truthing, and you develop these maps. And they tell you, where the river is today, where it's been in the past, where it could go in the future, and are there erosion hazard areas? And so looking at this one, if you can see kind of the middle of the screen, it's River Milepost 6 up here. do indeed have the roadway coming through that orange zone. So that's an erosion hazard area. And so what that's telling us is, hey, you've have your road in an area where it could be subject to a threat, and something you need to consider as you're progressing design. CMZ work is based on sound principles and approaches. It's been done for years, if not decades. The June 22 flood event created a unique opportunity to validate it. So, hey, we made this prediction, are we right? And so if you kind of look at that white scarp area, not the right kind of white area up here, we predicted that, hey, your road's in an erosion hazard area. What did we see? Oops. That one, the other one, forward. So aerial imagery, which again was in Karen's slide a few slides ago, lost a couple hundred feet of the roadway there in the Trout Lake, in the Trout Lake Reach. So you hate to see infrastructure lost, your friends and colleagues hurting and trying to have to repair stuff, but I guess refreshing is the right word, that, hey, these were accurate, and we saw it in other areas where we had CMZ maps and photography as well. Okay, so we've talked about identifying the hazards, fluvial, geotechnical, compounding hazard rain on snow, assessing, do those threats interact with the roadway? Okay, if they do, we need to start thinking about what are solutions that we can implement such that, again, it's a resilient system, can survive these future flood events. And as I said, they kind of started falling into two categories for us. And the first one was realignment. So again, if you've got a roadway overlapping a threat zone, whether it's that erosion hazard area or bottom of a landslide or other things, well, just move it, right? Take it out, move your target so it's no longer being hit. Easier said than done in the park. They're very sensitive to developing new land impacts. Might be willing to embrace a little bit more risk than something you see on an interstate highway. And again, we are still in the EA phase, so can't disclose the graphics and areas that we're looking at for realignment, but this is a classic example from US 34, Nick. Horseshoe curve up in the Big Thompson Canyon. That outside bend was lost in the 2013 flood events, and working through that project, doing the permanent repairs, said, hey, let's just swap the river and the road. Get rid of that problem. It's not going to happen again. The other group or bucket of solutions we're seeing are called tolerant features. So you're at a location, there's a threat. What can I do to survive it? And there are choices. I can start with something simple and more green-based, kind of what you're seeing here on the screen. This is a biotechnical rockery wall. Get more nature-based and certainly can accommodate lower flows. And then you can, run to the other end of the spectrum. And let's put something hard and gray in, so to speak. But if you got a big broad floodplain, a low-lying viaduct might be your solution. You can get the design those foundations to survive whatever. That river is going to self-organize, meander, waltz, do whatever it wants over the course of its life. Okay, so now we've got various solutions out there, and we need to choose which ones do we want to move forward with. And that's where we talk about framework. How do we go about choosing these? And within the last 1 to 2 decades, there's been progress in the transportation space about how one can go through and evaluate these. Not as mature as maybe the building side of things, water, wastewater plants. They've been doing this a little bit longer. For the Northeast Entrance Corridor, we mimicked a good majority of the CDOT process. So in the middle there, their risk and resilience manual. And it's just worth noting, top right, got some NCHRP documents out there. But what is currently happening is NCHRP is undertaking a project that looks to standardize how we assess transportation infrastructure for risk and resilience. So that's going to be a huge plus. One of the biggest things we're doing is benefit cost assessment. And this really looks to answer the question, are you getting good return on your investment? So given options at an area, whether it's the realignment, different types of solutions. Okay, what risk is associated with each of those? What cost is associated with each of those? So you run through and you're doing that math, ultimately giving yourself these ratios. And the way it's set up, a BCA over 1 is good. It says, hey, I'm buying down risk, I'm making smart investments. And I guess, costs there, I know user costs. So it's hard to make this number work if you don't include user cost in the equations. Just the construction costs can just not be significant enough if you look at loss of a highway or a route for a prolonged period of time. Okay, so now we've gone through evaluated solutions. How are we going to communicate this and work with, our client, their stakeholders, potentially the public? Where we're headed on our corridor, calling them linear heat maps. So at these areas where you either have realignments or options, we can color code our BCAs, get a nice snapshot, a good visual to kind of see, hey, where am I seeing good BCAs, or where are things bad? Where should I invest first? If you think capital improvement program, where do I want to focus my dollars first? Again, still writing the EA. I can't show results specific to our corridor. This is a screenshot from CDOT, where they have developed a comparable map. You're looking at highway criticality, again, some kind of color coding scheme. So that's where we are, looking to put a bow on here very soon for the Northeast Interest Corridor. And then another tool that we've been using well before the flood events, story maps in a GIS platform. And it's like Google Maps. That's what I try to tell people. Right? I mean, you can jump in, it's intuitive, it's not a big learning curve, and it's just a more immersive environment. And so we have used that to share way more information than you can share with traditional design plans. And we've also found it a better vehicle to communicate with the non-engineering crowd, when we're working with the geologists, right? I mean, the biologists, the historians, and all those people at the park. And so that's been well received. And we continue to leverage that. We'll be pulling over that BCA type information in that platform as well. Well, takeaways. Different ways to incorporate resilient design. You said, hey, just move the road out of the way if that's an option, or hey, I really need to stay where I am. What can I build? What are my options that can be constructed that it's not going to fail as such in the future? There are various frameworks out there and approaches for evaluating these things. And right now, I'd say it's kind of generally left up to the project teams, the owner, designers, stakeholders. What's the best approach? And so getting to that NCHRP level where there's more of a standardized approach across the nation, I think is going to be a big positive for the industry and make it easier to do this stuff with more consistency probably. And communicating with non-engineers, like I said, the story maps and what we've been able to do with that kind of technology has been really valuable. Again, you can share way more information than what will be shown on plans and profiles. I'd say in a more immersive environment where it seems to be digested better by the reviewer as well. And with that, I'll open it up to questions.
I guess I was thinking a little bit back to, the stream morphology and all the trout habitat and how kind of trying to predict the future when you're designing your resilient features on the roadway and how to predict what future flood events will be as far as habitat and how to.
So is that more for you?
We use the CNC mapping, to a certain extent to say, well, I might go over here, but this might be the next place to occupy. And then when you do use that along profile to see, well, this is where they're setting the score, this is something you can transport reach versus the response reach. So you can kind of get at it at a larger spatial scale. It's really hard to get down to the brain size, so you got an extra. But you can definitely classify the reaches by, you know, what's most likely to change based on the transportation response. There's going to be local erosion, local deposition. As you have, you know, a trip coming in, local sediment deposition, you know, and then downstream of that, usually it's dropped all the load now. You make larger scale classifications of high risk to low risk, but not down to the.
Asked a similar question to what I asked before. Looking at your presentation after your presentation, that looks like a landscape or a landslide landscape where you've got pretty much nowhere to go without being impacted by a landslide.
Right.
That's a really tough place to put infrastructure. I used to have to invest in it, so you don't run out of money, you don't run out of patience. So,
Yeah.
you know, what is the long-term solution? Is that something that?
Yeah, well, we started with, again, pre-flood, call them spaghetti plots, right? So big picture of Lamar Valley, for example, we probably looked at 20 different routes through there. I mean, moving the road 10 miles the other way, a tunnel. I mean, we threw out everything. We know the park doesn't want a tunnel, but hey, you could, you know, do it up here and go around the back and, you know, presenting any and all reasonably sane options that one could consider. And then we try to work through that with the park and Western in terms of, yeah, cost, mission. You know, again, it's a little different working in the park.
Yeah.
You know, they lie lightly on the land. You know, they don't want to see the infrastructure. You know, they needed to get people around, and particularly to Cook City and Silvergate, but you know, it's secondary to what the experience they want to offer. And so I don't want to speak on their behalf, but they might be willing to embrace a little more risk than again, an interstate highway, right? But yeah, you run into areas where it's
They have to replace them.
Yeah.
Yeah. Interval.
So that was something we talked about too, is like, you know, if you weren't constrained by government procurement rules, the best solutions at those Dry Creek crossings could be stage a motor grader there. Your next flood event comes through, you just plow it all off, because those crossings were generally, we were finding, properly sized to carry their debris flows. So your emergency response is not, don't put a bridge in twice as big that you don't need. Put in, you know, what's going to open the road the quickest. But yeah, FAR and whatnot won't let you do that. So. How do we determine where the channel might go in the future? So I will defer to one of these two or three on that.
So you, relative water streams faster. And then basically it looks at the terrain, so here's the river, this is my data, the elevation of the land around me. Things that are closer to the elevation of the river, closer to the river, probably. We started with floodlines there, playing off. Then you start mapping those areas that are close to the river, so their elevation, and then the areas that are highest, you know, above the river, you can say, well, the river's never been very healthy, and then you start mapping. You know, you can often see in those rasters, you can actually see the little channels where it is again, and you start mapping those hazard zones based on, but it's all based on the relative elevation of the terrain and the areas of the river. I'll just say that King County actually trying to do that approach. They are, so they all good. Okay.
Looking at the emergency stabilization you mentioned earlier on that road, like being riprap. Are there, I'm curious about the integration, particularly of root wads with attached stems that are anchored underneath the road. I've seen similar instances occurring on the Big Thompson, the Colorado Water Conservation Manual. Got great delineations that have been input by engineers projects in New Mexico with that technique. I was curious if, really a question for Craig, if there's been any shear stress modeling with that type of interface feature solution as far as increasing surface roughness and what resistance it has to increase shear stress.
I think you looked at that. We looked at that, not on any models that presented earlier, but other locations in part. That different reduction types and how that will change roughness values. And reduce shear stress.
Like in a national park setting, the lend itself are to learning those interface features rather than just soft or paper and or.
I don't know if Nick has something to add or a question.
Yeah, I'm under the partition of stress, that you can, that off your stress and say this, well, that kind of bed, that kind of off ways that we can. Think about it, otherwise you just look at shear stress and think your root water blow up, right, so.
Yeah.
Yes, so shear goes to the bed materials, but these dissipating. You know, we looked at that, but we don't use the video over lots of structures that actually maintain does the stability analysis. We actually did design a back such a structure for the park. One of them, but A is when a mixed polys paint wash from Washout. He did the design of that structure. What the problem we ran into frankly is that at that time, the Corps of Engineers person in Wyoming said, oh, this has to be stable 100 years. It ended up being up. The park said, I don't want that. So we have to come up with a design standard that, you know, looks natural and doesn't have to be stable for 100 years. Because then you have a tank that wants to look at the tank.
We're starting to have those conversations. So we're hoping that, you know, this is, you know, you're not in an urban setting. If this debris were to break loose, it's not likely to damage built property.
Right.
Just put into
So you're not introducing a foreign material at that
No.
point. It doesn't go out.
we're gonna reevaluate that. We're gonna keep doing those kind of designs. But street structure is not unusual.
Okay. Thanks, everybody.